And I will share you guys this starting file as well as the last time. Okay. So when you open this starting file and go to Mesh tab, you can check the existing soil materials here, steel and concrete, as I said. And here, under the property, you can check soil layer as assumed by embedded beam and ring concrete assumed by beam element. Okay. So firstly, I will import the CAD file, the DWG format. And this CAD file also will be provide you guys. Okay. And first, I will intersect the lines. So go to Geometry tab and select, click the intersect function. And select all. Control A is a select all. And okay. Then the lines are divided based on the point, as you can see here. Okay, so next I will create the face, and I will select outlines. Okay, and I will imprint the lines on the face. So go to curve and select the base face and select all lines. And I will check direction of shortest path line here. And okay. So after I imprinted lines on the face, then I don't need these curves anymore. So I will delete these curves using delete key. And as you can see here, the lines are staying there. Okay. So the next, I will give a property on the face first. So using this property control under Mesh tab, and go to Face tab and Property Fill, and select first layer and apply. Change the property, select the second layers, apply, and keep going until the last layer. Okay. So when you use this property control function, and you don't need to give properties when you generate the mesh. And also I will do the control the size of mesh. So select the edge, and you can give a mesh size under here. I will give a 0.5 for slope face. Here, apply, and 4 meters for outlines here and here and here, apply. And also you can give a linear grading. Start length is 1 and end length is 4. You need to check this arrow, the direction. Okay. So as you can see here, the start rank is 1 and the end rank is 4. Okay, so now I finished to create the geometry, and next I will generate the mesh. So I will change selection method to face and select all, Control A, and right click. Then you can see generate mesh here. I click this one. And I will give a size of mesh 1 meter. If you gave 1 meter under this window, it doesn't matter under this part because you already gave the mesh size of 4 meter. So the mesh will be create 4 meter under based on these points, but the rest part without this point will be generate a mesh with 1 meter. So property, you don't need to assign the property because I already assigned the property using property control function here. So it doesn't matter under here. So for the FOS check, the factor of safety, I will generate the mesh with a higher order element. So this means a node will be create one more between the two nodes. I will show you later. And I will check on this register each mesh item independently. This one, check. And okay. 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 So as I mentioned that if you uncheck the higher order element, the node will be created under this point. Let's say for under this element. So if you uncheck the higher order element, there are 4 nodes at the point here. But if you check the higher order element, then when you see the nodes, as you can see here, the node will be create one more between those two nodes. Okay. So when you want to check factor of safety for slot stability, normally we are using you need to use the higher order element. Okay. So the next, I will generate mesh for the ring concrete. So I will hide every mesh and show the geometry. And I will use this extract function for the ring concrete on the slope face and edge ring concrete. And there are 4 stages of excavation. So I will create 4 ring concrete for each excavation stage. So I will give LC-1 here and here, apply, and 2 here, here, apply, 3 here, and 4 this one. Okay, so when I hide, then you can see the generated mesh for the ring concrete, and also you can check under mesh tree here. Okay, so the next I will generate the mesh for the soil layer, and I will use this create function and choose a 1D and change the property to soil layer, and I will give the name SN-1 for first layer of soil layer. And when you use this element create function, the 1D, you need to select starting point and end point. Okay, so that means a node will be created on the starting point and end point. So there are two nodes. That's the SN-2 from here and here. Apply. Third layer, starting point, end point. And here. Okay, so I will hide the ground mesh. Okay, so this one is rain concrete, and those things are soil nails. Okay, so next I will merge the meshes to distinguish the excavation stage. So merge this one first. So from here to here is the first excavation area. So select those two mesh set and right click, merge. Okay. Okay, so it is okay because there are two different properties, this one and this one. Okay. And you can check properties under properties window here. And this one is fear. And this one is not fear, but it is okay when you merge it. It will not be combined the properties. So it means it's not effect to the properties or when you merge the different mesh set. Okay, so others, I don't need to merge it, and I will change the name. AX1. You can change the name using your F2 from your keyboard. X4. And you can check one by one, select, unselect. X3 and EX4. Okay. So next, I will give a boundary condition and surcharge. So I'll give a boundary condition first. Go to static slope analysis tab here and click constraint. Go to auto tab and I will change the name BC, the boundary condition, and okay. Then you can see the boundary condition has applied on the outline. Okay, and the next I will give a self weight for the initial stress for the stress analysis. And self weight, just change the name and okay. Then you can see the arrow has created at the middle of mesh set. Here is a self weight. And next, I will create the surcharge using the pressure here. And select edge, and I will show the surface edge. And select this edge, 10. And I already divided the lines for the surcharge from the CAD file. So you just one click on here and change the selection method to edge. And the surcharge is 10 kilonewton. Okay. define the water level using the nodal head, not lines. Okay, so click nodal head, and you can give a water level with the height. Total means height, and pressure means pressure. Okay, so when you press F3 your keyboard, then you can directly check the distance from point to point. So it's 39 meter from here to here. So the initial water level is under this line. So it's 39 height. So give 39 total. And right side initial. And you need to select the nodes like this. And you need to careful when you select the nodes and apply. And left hand side initial. So I will uncheck here. Okay, apply. So this nodal head function is different with the water level. This water level is just create the lines for the water level. So when you draw the line here, so during the excavation, maybe you will draw the lines like this, like this, like this. That means when you define the water level with the lines, it's this part we will create the water level manually because you already defined the water level using the line. But if you are using this nodal head, then you need to give water level, the water condition under the nodes here and here. So under this middle part will be calculated automatically by GTS NX using some formula regarding to water. So the water level will be created automatically under this mid part. So that means if you want to check the water drawdown, this nodal head is better to check the water drawdown. Okay. So the next, I will create the water level for first excavation. So hide this EX1 mesh set, then you can see the surface, the floor of the first excavation. So select the nose on the floor like this, and left side EX1, and I will change the type to pressure and give a 0. That means here the water pressure is 0, means here is head. Apply and hide second excavation mesh set and select the nose like this. Okay, so keep those things and EX2. And apply and hide this one, the next stage. And you need to careful, as I said, just select the nodes on the surface, change the name 3, apply, and the last excavation, select the nodes on the surface here. Okay, and 0 and 4. Okay, So now I'm finished to define the water level for every excavation stage. And under the slope surface, you don't need to define the water level. So this part will be create the water level automatically, considering this nodal head and this nodal head. Okay. So today, just now, I've finished to proceed today's session, and tomorrow I will do continuously to define the analysis stage using the semi-coupled analysis. It's different with the stress as excavation works. I did create the geometry and generate the mesh and apply the boundary condition and self-weight and surcharge here. And define the water level using the nodal head instead of the water level line. So from now on, I will define the analysis stage. So need to go to analysis tab here. And right click on here, then you can see add construction set. I click this one. And as I said yesterday, I will proceed the analysis with a semi-coupled analysis. So you need to select stress, seepage, slope stage type under here. And add. And double click this one. Then you can see the define construction stage window. In this stage, you need to activate and deactivate the mesh set and boundary condition and load for every stage, for each stage. So for the semi-coupled analysis, so for the initial stage, you need to carry out the steady state, the water stage. So I will give the name W initial, and I will activate every ground, and you can see the activate data only. You can control under this show data. If you didn't activate this one, then you can't see this one. So activate every ground, mesh set, and boundary condition, and initial water level created by nodal head. Okay. And save, and click new for next stage. Next stage is stress analysis. So need to change the stage type to stress. And in this stage, you just need to activate self-weight and clear displacement for initialization. Save. And next stage is activate the surcharge. Also using the stress stage type and activate surcharge here. And I will do the clear displacement again and save. And next stage, I will carry out the excavation. So the first excavation with the pore pressure analysis, change the stage type to steady state. And activate this water level for first excavation and deactivate this initial water level on left hand side and deactivate the mesh set, the first excavation. Save. And the next is a stress analysis for first excavation and activate the solenoid for first layer. So need to change the stress stage type and activate the ring concrete and solenoid for first layer. Save. And next, see page analysis for excavation 2 and second solenoid. So deactivate the second excavation mesh set and activate water level for second excavation and deactivate water level for first excavation. And need to change the stage type to steady state. Save. And it's the same as first excavation. Stress and activate second layers. Save. And the next step is third excavation for seepage analysis and deactivate and activate water level for third excavation and deactivate the water level for second excavation. Save. And next, the stress analysis for same step. Just activate third layer. Save. And the next is a seepage for last excavation. Change to steady state and deactivate the last excavation mesh set and activate the water level and deactivate the previous water level. Save. And next is the same step, but it's a stress and activate the reinforcement for last layer. Okay. And we need to check the FOS for this slope. So as you can see here, slope stability SRM. So check on this one for the last stage. Save. Okay. So just now I finished to define the analysis stage. And you can check your created analysis stage under this stage set and stage set 3, and you can check. Okay, and the next, after you finish to define the analysis stage, we need to create the analysis case. Right click on here and add a solution type. Choose a construction stage, and this one is this one. Okay, and title slope stability check, and go to analysis control, and I will assume it cannot condition for initial stage, so check on this one, the initial stage for stress analysis, and apply cannot condition. Okay, so if you want to see the strain from the result, you can control the output. So click this output control, and you can check this strain for the failure surface, failure line. Okay. Okay. So when you finish to create this analysis case, right click on here and click solve. Then it will be perform the analysis. Okay. The analysis speed will be different depending on your PC's condition. And under the tools, you can control the number of process to use for analysis performing. You can increase or decrease this one. And if you are using the NVIDIA graphic card, you can check on this GPU acceleration. Okay. So now it's finished to perform the analysis. So you can go to result tab, and you can see the stages what you created under here, the analysis. Okay, so this the C page analysis, from the C page analysis, you can check only for the water condition. And stress analysis, you can check displacement and forces. Okay, so let me check the displacement first under the last stage. Okay, so there are two last stage. One is just last stage, and one is SRM analysis. So if you want to see the displacement from the last stage, you need to check from here, not the SRM. Okay, so if you want to see the displacement, double click this one, then you can see total displacement, X direction, Y direction. There's no Z direction. Okay. And if you want to see the settlement of the ground surface under here, you can create the diagram using this cutting diagram. And so click first point and last point. I will change the direction to Y and preview. You can see the settlement on the ground surface using this on-curve diagram, as you can see here. Also, you can increase the representative point. There are 20 points because here the division is 20, and you can increase this division point, and I will increase the 30 from 20 and preview. As you can see here, the spacing of the points became narrow. Okay, and I will click OK. Then you can see the created diagram on the on-curve diagram tree here. And you can show and hide. Okay. So from the result, the ground settlement is around this value. And also you can see with the table format with the XYZ coordinate system and values is a settlement. That means you can check the settlement away from the slope excavation phase, like this. Maybe this one is will be take as a distance, and this one is settlement. Okay, so the next beam element force for this ring concrete. Bending moment and shear force. And for the solenoid, you can find the result from these truss element forces, action force. You can check it. If you want to see one by one, you just show one by one like this. Okay. And the next, I will show you how to check the water drawdown. Okay, under here, pore pressure head, I will hide this diagram. And you can control the stage using here. You can move to other stage using your arrow from keyboard, like this. Okay. And if we want to see just line for water head, the pore pressure head, you can use this multi-step ISO here. And data, you need to change pore pressure head and give a base value is 0 and plot. And you can see the pore pressure head from each stages with a different color like this. Or if we want to take the exact value, okay, so go to preview mode, click this one, and I will hide the meshes and show the geometry. And F3 is checking the distance, 1 meter. And I want to see the water drawdown from 1 meter away from this excavation starting point, then I will draw the line here. Location x 0 and -10. The line is here. I will check the pore pressure head using this line and go to post mode and go to result and see the pore pressure head from the last stage, and I will show every mesh. Okay, and using this cutting diagram function again, and starting point, click here, and end point, click here, and I will choose extraction. Okay, so maybe this point is 0 values for the pore pressure head, and I will click OK, and this is a diagram 2. And if you want to see the approximately height about this point, the 0 point, and go to show table, and you can take the y coordinate, then means 36 meter of height is 0 of pore pressure head, 1 meter away from this excavation starting point. And you can move other stage, same as before. Then if you go to here, then the values will be changed according to change the stages, like this. Then you can take the values, the height of 0 point for the pore pressure head using this one. Is an initial. So initial is 39 meter from here. Okay, so this is a finish about today's session for the slope stability check. I'm sorry about this. You can check the factor of safety under here. It's around 3 point something.